Hello, today I'm going to be explaining to you our full adder and half adder circuit combined with our full subtractor and half subtractor circuit. So first, you can see that clearly there are two main breadboards in this circuit. The first breadboard actually is the controller breadboard or controller circuit. We got the 7-segment display. Its controller is the 7448N IC that is also negated in these 2 pins. And we can also see that there are 2, 4, 6 switches in here and our input control or our input. We got actually 3 input in this circuit that can also be seen in our schematic. In this schematic, we use a dip switch, but it is also same with this one, which is a slide switch that we configured. And you can see that there are 3 inputs. But this circuit is in a mode of what we call a half adder circuit, half adder mode. So in half adder, you can see in this table that half adder can only get value of 2. This is in reverse, but if we output this in binary, it should be 1, 0, and the carry would represent 2. So maximum of 1 plus 1 it will be equals to 2. And 1, 0, 1 is 1, the sum of 1, 0, 1 is sum of 1, and 0, 0, 0. You can also see that half adder in the circuit was greatly used because we use the XOR output of it to directly input in our half subtractor. We also use it and this for our full subtractor circuit. Then the 6 switches that I mentioned here below are these circuits. So what are the purpose of those switches? So the purpose of those switches is to switch on half mode and full mode, and the sum and carry of the adder, and half mode and full mode of the subtractor. Also, the third group of switch, which is this one, is where we can switch into adder or subtractor. Then that goes directly to our controller of the 7-segment display that would output our numbers in decimal instead of binary. So here we can see that we need to confirm the theory of the half adder, which is 0, 0 is equal to 0. And here is 0, 0. I haven't flipped a switch and light doesn't come out of it. And next is 0, 1 would be equal to 1. If I flip a switch, there, it will be equal to 1. Now I'll turn this off and turn letter A and put A, and it should output 1. Now, if I flip both switches, it should output 2, or the carry. In this circuit, we can see that the carry in this part is in here. It is quite confusing to read the schematic, but if you know the circuit of a full adder and a half adder, you would instantly recognize it where we put our pins out. Now, if I flip the switch again, it should output 2. There we have it. Now, let's go on full adder mode. And going on full adder mode, we need to flip this switch, because this switch is switching from subtractor to adder, and this is from full adder to half adder. Now, if I flip this, there, you see that there's nothing yet happened because I haven't input any number in the start of our input. So in full adder, there are actually now 3 inputs. First is A, B, and carry in. The output would now have a maximum value of 3 because we have 3 outputs. Now, if I flip the third switch, you can see that here, this is confusing. Here, this is our carry in, or the utmost top value. This is carry B and A. Now if we go flip to switch, it would output 2. There. It should output 2 if you flip any of those 2 switches. Now if I even flip every switch, it should output 1 on every number. Now next is the tree. The maximum value, which is 1111, equals to a maximum bit of 3. Now if this one glow up, now there we go, we have a number of 3. Now we now go to our full subtractor, or I mean half subtractor first. We flip these 2 switches, and this switch is already on half subtractor. So half subtractor, if you have 2 ones, it will be the reverse of what happened in the full adder, and I mean half adder, which is if we got 2 ones, we get 2. And in half subtractor, we get 0 0 if we get 1 1, because we would technically reduce it to a number. But if you see here, we get a 3 if we get an output. We get a B there, because if you minus 0 1, and it would definitely borrow 1 and have a difference of 1. Now if we see here on the schematic, we have our half subtractor and full subtractor, where we utilize the half adder output of XOR. We can see here, let me focus. You can see here that XOR AB was got out of the pin and pulled apart, and we put it in our half subtractor. And half subtractor, actually what the only changes or the only difference is that you would negate the A and the XOR AB. And that's the only difference that you can see in half subtractor and full subtractor. Now, the same goes with the half subtractor. If we flip the switches, it would change to half or full subtractor. Now we check the truth table. So 0 0 is equal to 0, 0 difference, 0 borrow, 0 1 or 0 1. 0 minus 1 would be equals to 1 difference, 1 borrow would be equal to 3. So if I flip B, it would output 3. Now if I flip A or 1 0, it will be equal to 2. Oh, 1, sorry. Will be, this is on reverse again, would be 1 difference, 0 borrow, which is 0 1. And 1 1 would be equal to 0 if flip both. You see, there are 2 active inputs, and we get a 0. Now we change to full subtractor. In our full subtractor, we got now 3 values. Still, it would max out on a maximum of bit of 3, because it is only got 2 outputs. Now, if we check the truth table, 0 0 0 would be equal to 0. So 0 here, no inputs. 0 0 1 or input varo would be active. It will be equal to 3. Yes, equal to 3. Now 0 1 0 equal to 3 also. 0 1 1 would be equal to 1. Then 100 or 100 would be equal to 2. And 101 would be equal to 0. Because 0 minus 1. 1 minus 1, sorry. And AB would be equal to 0 also. All would be equal to 3. Now, that's all. Thank you and have a good day.